Good morning, everyone. Welcome to C&E Sales Monthly Webinar Series. Jeff Butler, the Technical Manager here at C&E. Today's webinar is titled Siemens Managed Access ID Key Switch. Our presenter today is Larry Ponziani. Larry's one of our automation specialists here at C&E. He's a double E from Ohio State. He's been with C&E for 3 years. Prior to joining us, he spent 30 years in industrial automation as a systems integrator in California. Just a few housekeeping items before we start. If you have questions during the webinar, please submit them using the control panel on the right side of your screen, and we'll address them at the end of the session. If you don't see that tool, click on the red horizontal arrow up in the upper right-hand corner of your screen. Everyone registered for the webinar will receive a link to the recorded session. Please be sure to attend next month's webinar, hosted by Heinz Knackstead. Heinz is one of our safety specialists here at C&E, and his topic will be logic behind the selection of risk reduction measures and circuits. That webinar will be hosted on December 8th at 10:30. I'll now turn today's webinar over to Larry.
Okay, thank you, Jeff. Like Jeff mentioned, I'm Larry Ponziani. I'm an automation specialist with C&E. Today we're going to be talking about the ID key switch. It's an option available for replacement potentially, or supplementing card readers or key switches. It uses RFID technology. So to start this out, just so everybody kind of gets a visual of what we're talking about, I'm going to play this short little video. I think it's about 30 seconds long. You'll see, hopefully that music's not too loud here in the background, but you know, they're showing it basically replacing a key switch. There's 4 outputs built in, plus there's also an output that tells you when the key is actually inserted. So there's actually 5 outputs on this key switch. So you can see, you know, depending on which switch is selected, it gives different levels of access, either 1, 2, 3, or 4, depending on how that key switch is actually programmed. So let's move on here. So first, let's talk about C&E Sales, who we are. What we're going to be doing, we're going to kind of do that whole who, what, when, where, why, and how to answer hopefully all the questions, and hopefully you'll find some potential in using this switch. There's a lot of versatility to it. But anyhow, C&E Sales has been providing automation solutions since 1978. 30-plus knowledgeable sales reps or account reps covering Ohio, Kentucky, Indiana, and Tennessee. We have 18 product specialists offering technical assistance in areas of automation, motion, safety, vision, controls. Whatever product that we cover, we have a technical specialist that can help you with any of the finite details of those products. We are a stocking distributor. We have 2 stocking warehouses. You can do online ordering. We do product seminars and workshops. You know, beyond the webinar series, we also have expos where we rent out, you know, big arenas or whatnot, and bring in all of our products that we represent. We also offer repair service, so even in legacy products, Siemens, Turk, Banner, and all the other products, we can help to arrange repair service and 24-hour assistance and product availability in case of emergencies. So that's a little bit about who we are. So the what is the Siemens ID Key Operated Switch? The Sirius Act is the series of switches that Siemens sells. The Sirius Act ID Key Operated Switch is an electronic switch based on RFID technology. So in the base of each of these little sticks is a little RFID chip, and inside the base of the unit there's actually an RFID reader. It helps to increase your tracking, OEE, security, access levels, and productivity in your application by identifying and authorizing users, groups, and/or for doing things like recipe setup, activations, etc. So you can use a key switch for, you know, identifying who the operator is, or you could use it to say you're going to run a certain product, you know, a certain size or a certain type or a certain mix or something like that. So the switch itself has 4 switching positions, and those switching positions are similar to like a selector switch, can be selected, and the availability of those 4 switching positions depends on the key itself. The colored keys, the green, the yellow, the red, and the blue, have fixed access levels. So the green only allows you to use the first position, the yellow, the first and second position, the red, the first, second, and third position, and the blue would be all 4 positions. Now with the IO Link version of this, which I would highly recommend over just the standard version, the IO Link version allows some additional features and programmability that would also utilize a white key switch, which has a programmable access level. So what you could do with these access levels, in addition to just for switching purposes, could be for identification of an operator, so that you know what those operators' capabilities are, what their training is, what they're allowed to have access to, and what they're not. So you can read these codes into the PLC and make decisions to allow that operator to access certain features or functions or capabilities of that machine. In addition, you can even use that, you know, for time stamping for whatever reason. You know, it might be if, you know, the downtime on the machine and uptime based on the operator, tracking of, you know, when they log in, when they log out, you know, just kind of making sure that you maximize your productivity on your machine. And again, all that is left to kind of the programmer and the designer of the machine to determine how to utilize those features. So what we're going to go into is how to use this key and where to use it. So let's move on here. So this next slide shows what the parts are that make up the ID key operated switch. So up at the top up here, you'll see 2 different versions of the actuator. There's a plastic actuator, which has kind of a black plastic body to it, and there's also one that kind of has a brushed nickel look to it. I know that looks just kind of like a gray plastic on there on the right, but it's actually a metal base, a little bit more robust, I guess, and gives you that feeling of robustness. You can see that also behind there, there are LED indicators. They're actually deep in the body of the electronic module that shine to show what the availability, the access level, and which of your outputs is actually turned on. The next piece is a plastic holder, just as your interface between your actuator and your electronics module. Then there's 2 different versions of the electronic module. One is an IO Link version, and the other is a non-IO Link version. So either one of these modules can work as a standalone unit, so they don't need to be tied into a PLC. All the features that we'll be talking about are available to both sides, and if there are features on the IO Link side, I'll be sure that those are made clear that they're for the IO Link version only. The difference in cost between the IO Link and the standard module is not very much. It's less than $50, and I would highly recommend that even if you're not planning on using an IO Link version, that you get the IO Link version so that it kind of allows future expandability or upgrades or whatnot. There's not that much difference in the cost, and it really opens up a lot of nice features. So we'll talk about those features here real quick in kind of a coarse detail here. The standard version has fixed features, so none of these features can be adjusted, where in the IO Link they can be. But in the standard version, you get the full standalone functionality, just like in the IO Link version. You get incremental switching, which means that as you turn your dial on your selector switch, it goes from turning on input or output, I guess, 1 to 2 and then it goes from 2 to 3 and 3 to 4. So really only one of those 4 outputs is on at any one time. Whereas in the IO Link version, you can turn on a feature that actually does cumulative switching, if that fits your application. And what that means is that when you turn on 1 and you switch it to 2, it leaves input 1 on. You know, when you go to 2 to 3, it leaves inputs 1, 2, and 3 on. The next feature with the standard, there's no position memory. So in other words, if you pull a key out with the standard, it will, and before you program anything in the IO Link version, it will just turn off all your outputs. But in the IO Link version, it does have a position memory setting so that when you pull the key out, it will maintain whatever the last position and outputs would have been. Similarly, with the power cycle, if you cycle power on the standard version, when it comes back, it's in the off position. And in the IO Link version, you can select it to go back to what it was when the power went off in the first place. And again, if that meets your needs, it's a feature that's available, but it's a setting that would have to be set. Okay, the next feature for the standard version is that with the standard version, you can only use the 4 colored keys, the green, the yellow, the red, and the blue, for your authorization levels. And then the IO Link version, the white keys are codable, so you can select a access level based on that what you program in for that white key. And then additionally with the IO Link version is that every key, including the 4 colored keys, the green, the yellow, the red, and the blue, have a unique code that's built into them. So every key has its own code that can be used to identify your operator or for whatever other identification purposes you're using this for. It's 100% unique between key to key to key. So if you ordered 100 keys, each of those keys are going to have a different key code associated with each. We'll go into more details on these in the coming slides, so let's move on. So what are the different modes? We've already talked about this a little bit, but when you power this unit up, without any key in it, all of the positions show as being red, okay? And no positions are selectable without an ID key plugged into it. And they fit in there rather snugly. You know, they're a good, solid click fit into that key switch. So once you plug in, like for instance, a green key, initially it allows the yellow being a permissible position. When you click the switch handle over 1 notch, it will turn on your first output. And that's the only accessible key position for that particular green key. The yellow key, the red key, and the blue key act similarly, but the yellow key gives you 2 access positions. You can see those being actuated here. The red key, 3 positions, the blue key, 4 positions, and then again, the white key on the IO Link will allow you to program that in. Additionally, if you look over here on the left-hand side, in fact, I think the next slide covers this. In fact, let's just go to the next slide here. It's very similar here. The 4th position, the DQ.4, is an output that comes on whenever there is a key inserted into your ID key switch. So as soon as you plug in that key, this output goes to 24 volts. Then as you turn on the key positions, so when basically there's a green light on your key positions, that the first, position 1, when it's green, turns on output 0. Position 2 turns on output 1, 2, oh, I had an error, typo there, but that should say 3, would turn on your output 2, and position 4 would turn on your output 3. So, there is a little bit of an offset there because of, it starts at 0 there. And basically also if you did the IO Link version with the cumulative switching, that allows you to turn on the first output. When you click it over again, it turns on both the first and second, the first, second, and third with the next one, and so on. It would actually turn on each of those outputs cumulatively also. So the outputs mirror the position of the green light. So anytime there's a green light on, it turns on those outputs. Well, let's move on here. So this goes into what are the additional features on the IO Link ID key switch. Again, I would highly recommend going with the IO Link ID key switch, even if you're going to use this as a standalone unit. And as a standalone unit, you could wire these outputs into your PLC to supplement your logic. You know, I'm sure everybody understands what I'm talking about there. So with the IO Link ID key switch, you get everything on the standard ID key switch, and additionally, each key stick has a unique, readable, unique code that you can read through your IO Link into your PLC. We'll go into that a little bit here in a moment when we get into some live action here. We'll get online with one of these. The switch positions can be cumulative. I've mentioned that already. The selected position can be set and held after the key is pulled. These are all selected features, so you have to go in through the programming tool to select some of these features. The selected position can be saved through a power cycle. The white access keys have a settable access level, so you can actually even change an operator's level without having to give them a different key stick with the white keys. So, you know, it's kind of a, you know, again, it's left to the designer of the system to determine what key is appropriate for what operator or for what function on the machine or whatever. The white key sticks are also saved in memory locations, I should say, on board the electronics module. So built into this electronics module are 50 memory locations that are basically saved to keep these white key stick access levels stored within that key switch. What that does is, again, allows you to use these as a standalone unit, even though there's an IO Link capability to it. So additionally, features are available with any IO Link master, not just Siemens. So these would work just fine with a Allen Bradley system, Turk masters, anybody that has an IO Link master. And we'll go into what the IO Link is here in just a minute. And you know, it's an open standard that is it's really catching a lot of traction within the industry. So the key switch also has a programmable name label feature for the switch itself. So in other words, when you get into your IO Link and you're looking at your master, some of the masters have multiple positions. The master that we'll be looking at, we're working with here, has 4 IO Link connections to it. Each of those switches, you can put a name label in, you know, it's an electronic name that you can plug into that unit. You know, you program it in, and then when you get back online with it, you can verify who you're talking with that particular switch, just to make sure you're not working with the wrong switch if you're working with multiples of these. The key level and switch positions are also readable through IO Link. So, you know, if you plug in a key, you'll know through IO Link what the access level of that key is and also what the position that you are turning on that key switch. So in other words, you don't need to but you don't need to wire in your outputs from your key switch directly into your PLC. It can be read through IO Link, and then the decisions can be made based on that data that's read in. Additionally, there's some diagnostic data. It's not very extensive. There's really not a lot to look at here, but it does give you some diagnostic data through the IO Link connection. And then the terminals that are specific to this, we'll go back a slide here. So if we look at the lower terminal strip here, if we go back to the terminal strip on the standard version, the three terminals there on the lower left are just blank. They're essentially meaningless in the standard version. Oops, I went the wrong way there. So in the IO Link version, you'll see you have the L+, the C/Q, and the L-, which are standard terminals for IO Link. And then also in the lower left of the electronic module up here, it's not labeled in this little graphic here, but there's a LED link. It's a status and activity link LED at the bottom. The other LED on here is just that it's got power. So again, with our who, what, when, where, why, and how, we're at the what level here. We got what is IO Link. IO Link is a serial bidirectional point-to-point connection for signal transmissions. I know we can all read, but I figure we might as well read it. But it's used for power distribution on any network, field bus, or backplane bus. An IO Link system consists of the following components: the IO Link master, which is typically something that's connected directly to your PLC, your IO Link device, which would then be connected to your IO Link master. Okay, the master sort of serves as your interface, but there's a plethora of IO Link devices, not just ID key switches, but there's all kinds of sensors, actuators, RFID readers, IO modules, valves, and so on. If you Googled IO Link, you would learn a lot more about this, but at this point we're not going to go into very much of a deeper dive into IO Link, because that's opens up a whole bunch of information that we're just not going to have time to cover here right now. But IO Link uses the unshielded 3-wire standard cables, like we're showing the L+, the C/Q, and the L-. And typically there's an engineering tool for configuring and assigning parameters of the IO Link. So in Siemens, which is what we're going to be looking at with a Siemens PLC, we'll be using a tool called the S7PCT, which the PCT stands for Port Configuration Tool. So there's a little bit more on IO Link. Just kind of shows a little graphic here. It kind of shows, your standard kind of industrial, PLCs with, computer and HMI. This one in particular is talking Profinet to some of your IO Link masters here. This master on the left-hand side is a plug-in module to the ET200S. They also have them in the ET200SP family. And there's also a module that's directly connected to the S7-1200, which is what we're going to be looking at here in a moment. Additionally, there's a ET200 Eco Profinet module that has an IO Link master, and you'll find IO Link masters across the industry with Allen Bradley, with Turk, with anybody that deals with PLCs and industrial controls are likely going to be diving headfirst into the IO Link technology. Then you can see, from the IO Link master, they're showing a lot of different types of devices: overloads, relays, contactors, starters, sensors. They're showing, it looks like, some proc switches there, some RFID readers. Whatever your module is that works over IO Link, that's what you can connect to your master. So it follows an open standard, like I mentioned, the 61131, which is, the industrial control one. The IEC 61131-9 is specific to the IO Link. The devices use a IODD device description file, and the IO means input-output device description. So you can do dynamic parameterization and automatic reassignment of parameters through IO Link. You have single uniform wiring, continuous communication at different selected baud rates. Some of it's fixed based on your master. Some of it is dependent on your cable length. Some of it are dependent on your devices. All right, so moving on here. This might get a little dry here. I'm probably going to move a little bit quicker through this here, not to bore everybody to death. But the who, what, when, where, why, we're already at the when. When to use the ID key operated switch. Authorization management system with 4 authorization levels. Freely programmable via IO Link, and that obviously is with the IO Link version. Easily handling thanks to color recognition. So the ID key switch operates in place of traditional key operated switches, card readers, even logins that people might use through an HMI or a computer. It's basically used for identification of authorized users of a machine or functions of a machine, and also could be used for recipe management. You can plug in a key that activates a number of recipe settings or conveyor widths or whatever fits your application. And the idea of this webinar also is just to kind of get your brain thinking about what types of applications this might work in. And I'm just giving some typical examples of that. The keys and switches are plastic coated, don't come in contact with the wireless interface. So what this means, these are IP65 rated. Okay, inside the actuator part, it is sealed again to IP65. It's dust proof, and I think it's equivalent to your old NEMA 12 ratings for people that remember that. So you have a degree of protection between your front panel and your electronics inside. So in other words, dust and water are not going to get in and penetrate your panel through these key switches. And everything happens wirelessly. So I think with key switches and especially like with card readers and that sort of thing, you do have a degree of penetration that you have to verify with those. So these are IP65 rated. An additional advantage over conventional keys is that the tag and the authorization of the levels of that key can be modified remotely. If you had a physical metal key, with all the notches in it and everything that an operator had to operate this machine, it does not identify any levels of training or access or availability of features that operator might be entitled to or not entitled to based on their training or physical characteristics or whatever. Let's see. In addition, a number of different evaluations are possible based on the particular time frames, during active production, or when configuring, even in faults. So, it just depends on how you program that. Moving on here, where to use the ID key switch. You can use it for either a supplement, like if you have card readers in place, you want to try this out as a different type of reader, you can put these in and program them to suit your application to supplement the card reader. You can use it to phase out card readers. You can use it in place, again, either to supplement or phase out key switches, or you can use it to initialize access levels. Like if a machine is crashing because operators aren't trained properly, you can use these ID key switches as a method of maintaining what operators have what training and what capabilities on a particular machine. You can also use these to track machine and operator performance, uptime, downtime, when the machine comes on, when it's shut down, maybe even power failures or that sort of thing. You have no passwords to forget or to get compromised. Somebody can't look over the shoulder of your maintenance man to say, okay, I saw what his password was. The key sticks can stay on the keychain, so an operator can put these on the keychain with his car keys so that when he brings them in the morning, he's got them because he's got his car keys. When he leaves at night, he's got to take them with him because he's got to drive his car home. So you maintain that verification of what operator is working on that machine. And again, like I mentioned, it could be used for recipe or setup management. It can be handled in a similar fashion. So if you're setting up your machine and you need to have a particular recipe or you need to set rails to a certain amount, even the color coding of the key switch, which can be seen at a distance. I mean, from probably 20 or 30 feet away, you can tell what color of key is plugged into that unit. You can even put markings on your conveyor to say, here's, we got the blue key switch in, so, move the conveyor width to the blue marking. I'm sure everybody can relate to what I'm talking about with that. In fact, I think this part matches the same slide as before, but I won't let you go back and see. So let's move on here. So why do you want to use these key switches? Again, we've talked about a lot of these things. You want to use them for supplementing your existing ID key methods, cards, keys, logins, replacing, or if you wanted to institute new methods of ID methods. And you can also use it for foolproof setups so that you don't have somebody that picks the wrong recipe on a machine and all of a sudden you're filling bottles with the wrong product or cans or whatever you've got. So for both foolproof setups and foolproof recipe selection. You can track machine and operator performance. You can get timestamps for your machine for logging. You can send that up to a SQL database. You can log in on your HMI, you can log in on your PLC, you can even do trending, whatever. Used for different modes on the machine, so you can have like a maintenance mode or a clean in place or a setup or something like that. That would be potential uses for this also. So your maintenance men may all have blue keys. That gives them the availability to get it into a maintenance mode that they can make a change to a setting, or the regular operator only has red keys. They can only take it to a certain level. And again, the keys are clearly visible from a distance. I guess it depends on the operators, but my guess is easily they could see it from 20 or 25 feet away. So moving on. So now we're into the how. This will hopefully get a little bit more interesting. How to add your IO link module, download the S7 PCT, download the IODD file, and the block library. There are 4 links here. What we'll ask you to do is, if you need access to those links, is to send an email to us, and we'll copy those over to you. Basically, the support site for the ID key switch is the first link there. The S7 port configuration tool is your second link there. And what that is a download that you would put in, and it works in conjunction with the TIA portal software for Siemens. Allen Bradley would have their own sort of PCT for their systems. And then the IODD file is something that's compatible with anybody's software. So it would be, it's equivalent to like a EDS or a GSD or GSDML file for a I/O card, for instance, for PLC, Allen Bradley or Siemens. So what that basically does is it gives the device description for that I/O module. And in this case, it would be the ID key operated switch. And then additionally, there are some blocks that are very user-friendly. We'll go over those in a minute, but they're also downloadable through that link there. So moving on here, and we're going to do a little bit of back and forth here. I'm going to jump into the TIA portal software here in a second, but what we're going to do, we're going to get into TIA portal. What we're going to be working with is an S7 1200 with a SM SM1278 IO Link module. This is a very, very economical combination to get you into the IO Link world. The S7-1200s start, the S7-1212, I'm sorry, would be the lowest level that would support IO Link directly on the unit. They are under $300 for an S7-1212, and then the IO Link module, the SM1278 IO Link module is also under $300, and you get 4 IO Link ports with that. The device tool, the port configuration tool, is a free tool that is freely downloadable from the Siemens website, and the IODD is also a free download. So we'll get into a little bit more details on this here just in just one more moment, and then in fact I think we're ready to go right now. So let me escape out of here. Let me hop over to my TIA portal software. Okay, so hopefully everybody sort of recognizes what we're working with here. This is the TIA portal software, just real quickly. It's very similar to anybody else's PLC interface. You've got your project tree on the left-hand side. You kind of have your working palette and informational section in the middle, and then your tools are over on the right. Okay, so for this particular project, I programmed in an HMI, and then I copied it over to a second HMI, so we had 2 different HMIs that we were using for some demos that we put together with this. But basically what we're going to do, we're going to focus on the PLC. So I'm going to double-click on this. Alternatively, I can just go up to, I can click on it and then hit Device View up here. But if we double-click on it, it takes the focus to our PLC and our SM1278. I'm going to blow this up just a little bit here. I don't know if this will be too much, but anyhow, you can see our S7-1212 is here. Our SM1278 is located here. So basically what we would do is, you know, we'd bring our 1200 into our project. We'd come over here to our signal modules. I think is it under, yeah, here it is. It's under technology modules, an IO Link master for SI. And if I could pull that over, you know, I could pull in a second one if I wanted to. You know, we could pull that in to our project, and you know, it's in our project. But we've already got one in there. That's what we've got to match our system. So now I've already downloaded the S7 port configuration tool. So we're going to jump right into that. Once you download it, it recognizes that it's going to be part of TIA portal, and it integrates itself in. Under the yeah, okay, so what we'll do, we'll right-click on our IO Link master, our SM1278, and then we're going to click over here on Start Device Tool, and that's our PCT7 device tool. If there were other tools, it would list them there, but that's the only tool we got. We're going to hit Start. It does take a second here, and it'll bring up a window that it knows a little bit about this already. I've already, oops, sorry about that. Just clicked away from it. Just trying to expand it here a little bit. So what I've done, I've already brought in the IODD file. And how we do that, we go up to Options and Import IODD. So whether you're dealing with an ID key operated switch like we're talking about today, or whether you've got any other IO Link device, you would come up here initially and bring in that IODD, which would define the functions and features and memory locations and everything that the IO Link needs to support that module. So I've already done that. What that did is that it brought over those modules over into our catalog over here. Okay, and then in under the IO Link version 1.1, which is what these are. There is a version 1.0, so you do have to maybe search around occasionally if you bring in an IODD that has different types of files associated with it. As you can see, we've got a number of IO Link modules. I'm sorry, yeah, IO Link modules associated with this project. What we did, we brought in, expand this a little bit, but basically we just brought in this Sirius Act module for ID key operated switch. So this particular master supports four IO Link devices. Okay, you can have this ID key switch on one of them. You could bring in a second, third, and fourth ID key switch if you wanted to, or you could bring in, you know, relays, contactors, starters. There's all kinds of sensors that are IO Link and that sort of thing. But again, you know, this webinar is about the ID key switch, so we're going to maintain our focus on that. So once you bring one of these into one of your four modules here, it's going to give you the ability that you can then access the features of the ID key switch. And that's what we're going to take a look at. So under, again, the port configuration tool for this switch, you've got 4 tabs up the top. Each tab has different features associated with it. I think I mentioned at the beginning of the webinar that, you know, each of the key switches has a name that you can program in, and that's what we did here. I just called it the C&E ID key switch, and then I put my initials on there, so in case somebody steals it from me, I can identify it. But anyhow, it gives some additional information, you know, that it's a Siemens, the part number, the firmware version, and that sort of thing. Again, some of these fields are, you can change, other of the fields you cannot. Okay, so obviously that's one that you may or may not want to set up. So the parameters section is where we get into some of the meat of the IO Link features that we've already talked about. So if you wanted to turn on the incremental switching mode, which I've already enabled, I can enable that here. I can disable it and it comes disabled out of the box. Okay, I actually physically went in and enabled some of these additional features, including the switch position memory. And what that does is that if you pull your key switch out, I should call it the key stick out, it will maintain the outputs that were there just prior to pulling that out. In order to change it, you'd have to put in another key switch. And then this next one, the switch position retentive memory, is if there's a power cycle, it will come back with the same key position enabled that were there before the supply voltage was removed. Okay, and then this next one, the individually coded ID keys only. What that does is that if it's enabled, it will only work with the white keys. Okay. So moving on. And then there's also a switch position delay. I think this is actually set for 2 seconds when before you change it. You know, the default is 2 seconds. What that does is that as you turn your switch, there's a 2-second delay before it actually activates that output. And what that does is that it doesn't activate things in between your 2 positions. Like if you wanted to go directly to output 3, with 0 in there, it would actuate 1 and then 2 and then 3. And they would physically come on during those transitions, where if you left it at the standard 2 seconds, or if you made it 1 second, it would give you a chance to change those positions without actually activating that output. Okay, hopefully that is understood. So moving on here, the set authorization level 1, 2, 3, and 4. Again, this is where you would set your activation level on your white keys. Okay, and when you do that, when you plug in your white key and you set an activation level, what it does is that it puts that key into a queue. And if queue is the right word, there are 50 positions that are built into the Link electronic module that sits behind the switch. And each of the positions remembers when there was a white ID key stick inserted. And it will remember, for instance, I do have one ID key switch. It's a white one, and the code on that is 1BFEC818 and 04. And I set that authorization level for 4. Okay, and if I had additional white keys and I set the authorization levels, it would start stacking those up behind the, wherever the next available slot would be. You can also delete, and you can delete an inserted key, or you can delete all the keys. So, like if a operator moves to a new access level, you can change that operator's access level to match what their training or capabilities, or if they're trained on a new machine or whatnot. So hopefully that is understandable. Then the monitoring tab will tell you when. This is some of your diagnostics. So basically it'll tell you what your authorization level is and what your switch position is based on your key. And you can do these live. I know I'm going to probably get in trouble going live with it, but it'll just take a minute. I just went online with it. And then I've got a blue key plugged in there right now, which should have an authorization level of 4, and it does. So when I switch this to position 1, which I just did, you can see it just changed it to 1. I'll go ahead and just switch it all the way over to 4, and there's our position 4. So all of these numbers are readable in through your PLC and the blocks that you download. So you can make decisions within your PLC without actually physically wiring your outputs from your electronic module into your PLC. When I pull the key switch out, you'll see that our access level goes to 0, but our switch position stayed at 4. And that's because our parameters back here are incremental, not our incremental, but our switch position retentive memory was enabled. So going back over to monitor, if I didn't have that enabled, that would go to a 0. The other thing is that you'll see our ID key switch is no longer recognized. There's no ID key switch in there now. And I'm sorry, ID key stick. So I'm going to plug in my blue key switch here again, and you'll see that X will come back on, and the 4 comes back, and then again I can change that access level back to 0, and so on. I hope that is understandable. The ready means that it's communicating with it. So you'll know if you go offline, you can actually make decisions based on that. Then some of the diagnostics, it gives you some further diagnostics of the system. It's not very extensive, but to me, one of the most important features of this is that the identification number, which is unique to every key switch. So if you bought 100 of these key switches, you would have 100 unique codes. Each key switch is unique. So you can take that into your PLC and make some decisions based on that. Okay. So I'm going to go ahead and get offline here, and a couple of other features of this. You've got some load with devices, or upload to the PG is your PC, and load to the devices. So highly recommend saving it to your PG when you're done with your configuration, so that it's retained in your project. And let's go ahead and we don't need to save the changes here, and we'll disconnect our tool. Okay, so now what we're going to do, we're going to go to our PLC and we're going to take a look at the code here a little bit. So when you want to institute this, there's some block downloads that you can get from the Siemens website, and again, we can send you that link. The IO Link Master is one of the blocks. It's FB 50,000. I guess they didn't want you to trip over any other numbers that are in there. But you know, the features of your IO Link can be monitored and controlled to turn things on and off on your IO Link Master. So what this does is that this is your control for your SM1278. Okay, and I guess I could go online with this, go into monitor mode. Hopefully we won't trip over ourselves here. We're only going to go online with our PLC. Go online. And then we're going to go into monitor mode. Hopefully everybody knows about the little goggles for monitor mode. As soon as it's done going online. Well, looks like, there we go. Okay, so just like any other PLC, you know, we can get some monitor status of these. If there's any issues with your IO link, they'll show up here. There's some diagnostics lights on the unit also. So there's nothing wrong with this. This is set up just fine. We're not going to talk about that very much, but what we are going to talk about is we're going to go into our key switch block here. Okay, and we're going to take a look at the setup with this. The port number is what port is that ID key switch plugged into. And actually, I think I've got this plugged into port number 1. So let's modify this to a 1. And okay. Okay, now we should be reading that key switch properly. And I know I'm running out of time here a little bit, so we're going to maybe just gloss over this here a little bit, but what I do want to show you, let me go to my tags here. In fact, why don't we just go down, I think a little bit further down here. I'm going to open all my networks here so that I can see all of them here. What I'm doing with the code on the key switch is I'm basically doing a comparison to see which, it's in here somewhere. Here's where I'm doing my comparison. So what it's doing is it's looking at the different values for each of my key switch positions. So this particular key, without going into a lot of details here, this particular key has a code of 3F, OE or 0E, BF, 17 and 04. These are all hex numbers. They're, you know, dual hex numbers. So there's essentially 10 hex numbers that identify a key. So if you do the math, 2 to the 10th is a pretty big number. And each of these is unique. Then I'm just doing a comparison based on, you know, whether there's a key detected or not. Because a key, when there's no key inserted, I'm going to pull this key out. All these fields should then change to a 7F, FF, 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 and FF. And of course, because we're live, it's not going to do that. I'm not sure exactly why. I'm waiting for it in case it's still thinking. Of course, we're going to have trouble when we do that. But anyhow, what that means is that if you don't have a key inserted, it also gives you a unique code that you can take a look at. We're doing a little bit of logic in here to determine which of your IO link outputs is on, and then up here we're doing a look to see what your authorization level is. So we did a little bit of code in here. Ultimately, with the IO link and, you know, with our automation specialists, we can help you with all of the programming and setup capabilities within that. But again, you know, the user-friendly blocks associated with this are free for the user. They're freely downloadable from the Siemens website. All right, so again, I think I'm just about out of time here. Let me jump back over to my PowerPoint here, if it will let me. And again, my system is not letting me. There it goes. let's go back over to here. Okay, so I think we covered pretty much what we wanted to cover as far as the who, what, when, where, why, and how. And, you know, just to kind of put a quick little recap on what we're dealing with here. The ID key switch is usable as a standalone. It's got 5 digital outputs, 1 for the key inserted, 4 for each additional switch position, allowed by the access level based on what the key's access level is. The colored keys have fixed access levels. The white key has a programmable access level through I/O link only. It's usable as an I/O link device, retains all features of the standalone, but the I/O link reads an access level, switch position, as well as reading the unique code to each key stick. I think that's one of the most powerful things that this thing has going for it. It can identify operator to operator to operator rather than just what the access level is. You can show the setup. Oh, I'm just reading off of here. But anyhow, we did this setup with an S7-1212 and SM-1278 I/O Link Master, which has 4 I/O Link ports available to it, and we use the S7 port configuration tool to do this setup. And we showed a little bit of the demo in there and went on there live without getting into too much trouble there. That the switch is usable on any platform that has I/O link. All right. So I've got a couple of informational videos that were done by Siemens, but I think that we're just about out of time here. Let me just see what we got. I don't want to bore you guys with the videos, but again, if anybody has any questions, you can fire those in there. Doesn't look like we had a lot of attendance here, but that's all right. They don't know what they're missing. And so contact your account manager for further information or to arrange a demo. I hope this was informative and gives you some ideas on the use of this technology. And again, I want to thank everybody for attending. And again, if you do have any questions that come up afterwards, just contact your account manager or your boss or whoever. Okay, so that wraps it up. Jeff, if you're online, do you have anything to add?
I don't, other than thank you for the presentation on this new product. And
Okay.
Everyone who registered for the webinar will receive a link, so they'll be able to watch it at their convenience. So I'll go ahead, and we don't have any questions now, so I'll go ahead and stop the recording and shut down the webinar. Thank you, Larry.
Thank you.